There we go. Is it working now? Or it might be really loud. Yo, it should be working. Hello, hello, hello. Tell me if we're working, team. Welcome to Nutshell Maths Probability. Chat's gone dead. Please tell me I'm not muted, team. Nutshell Maths Probability today. Right, here's your 3 steps on what's going on. Firstly, we're doing a maths tutorial, and so it's really important that you make a Twitch account so you can answer questions. Twitch is free. Everything's free. I'm giving this to you for free. Then you can chat and ask questions. Questions make this tutorial so much better. Without the questions, it's boring for me, boring for you. Lastly, exclamation form in the chat. Might be no sound. Yes, I think it's working. I think it's working. Thank you, thank you, thank you. It all just came through at once, right? Exclamation form in the chat, team, and you'll get a form. Right, moving on. How to make best use of this tutorial. Right, same stuff as yesterday. Right, man, my internet's going real slow. Same stuff as yesterday. Firstly, follow along with the paper. Exclamation questions, exclamation answers. You'll get the paper. You'll be able to follow along with me as we work through all of the questions. Okay? Ask lots of questions. There's heaps of us in the chat. You can ask questions. I will see them all. I will answer as many as I can. And then lastly, exclamation commands gives you a list of commands that you can put in the chat, and it will give you information. Right? Last but not least, get your graphics calculator out now. Right? I will stop. I will let you get it out. Get out your graphics calculator. I've got mine here. You should have yours in front of you. You should have a pen. You should have some paper next to you and ready to go. And always remember, what I do. Oh, what? That's not what I wanted. What I do is not necessarily the best. Your teacher may teach you in a different way. They may know stuff better. Can't hear. Does it sound okay? Should be fine. What I do is not always best. It's good, Sandy. You need to sort that's on your end there. Okay, we're supposed to have a graphics calculator for this exam. Yes, you 100% need a graphics calculator, especially for this one. Okay, especially for this one. Refresh if it's not working. Refresh. Okay, let's have a look. We're doing the statistics, the probability paper. It's with 4 credits. We're just going to jump straight in. I'm not going to teach anything too much from scratch. I'm just going to go in, ask lots of questions. Let's see how we go. Before we tuck in, I'm just going to briefly explain what this paper is made of. Okay, so that's green. We've got 3 sections. Okay, the first section, not in any particular order. Tables. Okay, where you have all this stuff like this, and you do this one out of the total, and you get a percentage or something like that. Right? Chat's gone dead. Tell me if the quality is not good. Okay. Secondly, we have trees. Thanks for the compliment on the colors. Where we have stuff like this, and we calculate the probability at the end of each of these, and do stuff with that. Right. And lastly, that's quite nice. We have normal distributions. Okay, where we have a standard deviation, and we have a mean. This is the 3 sections of your exam. Guaranteed you'll get one whole big question on tables, one whole big question on trees, one whole big question on normal distribution. Normal distributions. Okay. So, that's what we're going to focus on. You should know how to tackle each of these. If not, we're just going to go through it. Let's have a look. Let's cancel number 3. What? Okay, let's look at question number 1. Right, this is the table section. You can tell by the table. Let's have a look. Regular surveys are taken of New Zealanders to find out the state of their health and well-being. Number 3, if you're talking about normal distributions, they're the easiest ones. It's all on your calculator. Let's have a look. Random sample 2,500, blah, 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 blah. What proportion of these obese young adults in the sample were male? So, what proportion of... I do it like this. Now, if you're in my class, you'll recognize this. Okay, I do all probabilities with this phrase, want over pull. The thing you want out of all the things that are possible. Right? So, Laser Kiwi's way ahead. So we've got the thing we want. The thing we want is of obese young adults in the sample. Right? Or obese young adults that are male. So, we're going to grab obese young adults that are male. That's our want. Out of what proportion of obese young males in the sample were male? Out of 507. Yeah? Out of 507. Because we only want the obese ones. We don't want any that are not obese. We don't want that category there. Okay? So we only want the obese ones. We don't want the non-obese ones. So 222 out of 507. I don't have a graphs calculator. You should 100% go buy one. It's basically buying credits. Right? You can turn this into, if it proportion just means probability, if it asks for percentage, then you should put it in a percentage, but we can just leave it as 222 over 507. Easy achieved. Let's move on. At the time of the survey, there were known to be about 585,000 young adults in the age of this. From the results of the survey, how many young adults in the age group would you estimate to be obese? So, what's the probability of being obese? Well, it's going to be all the obese people out of all the possible people. Okay, all the obese people out of all the possible people. Then, with this, well, let's figure out what this is. 507 out of 2,000, 2,500. 0.2028. Times the number of young adults in the age of this. So how many young adults in this age group would you expect to be? Yeah, so we've done that. And expected value, whenever it says expect, we think we have to times the probability with the group. Okay? Times the probability with the group. I want to re-highlight it. So we're going to do 0.2028 times 585,000. Now if I've made a mistake, you've got to tell me, because I will make mistakes. Yeah, TradeMe is a really good place to find calculators, or cash converters is often pretty good. .863.8, I would round this to 11864 because you can't have 0.8 of a person. So we would expect 11,864. That's an easy merit. Let's have a look if we got it right. Oh, did I didn't add enough zeros to my calculation. That's okay, that's just a typing error. Times 585,000. There we go. Told you I was going to make a mistake. No one called me out. Come on, team. 11,863.8. So we don't need to do any rounding. That's it there, and we check our answer. We've got it right. Well done. Oh, it's only achieve. Sometimes that's a merit. Often it's a merit, but that's only achieve. Yeah. Oh, oopsies. Physics was hard, team. Right. Nicely done. Let's look at this one. There's going to be a lot of flicking back and forth in this exam because it's sort of 2-page and we can only look at 1 page at a time. Now, this is a claim type question. Oh, not claim. Claim. This is a claim type question, and in a claim type question, we need to calculate the relative risk, which is one probability over the other. Okay, let's have a look at the question. So newspaper surveys, this is a recent survey of this shows females are more than 20% more likely to be obese. So females are more likely than males. So it's females versus males. Females obese, right? Females obese versus males obese. Okay, I lay it out exactly like this, and I recommend laying it out like this with this versus sign here, and it's going to stop you getting confused on which way you put it over the top. Females obese versus males obese. Well, females obese is going to be obese females over all females versus obese males over all males. That makes sense, doesn't it? Boo sexist. Hey Hamza, how are you? Okay. If we have obese females versus all females, obese males. Now this is where we've got to flick back and forth. Obese males, there's 222. Oh, let's do the females first. Obese females, there's 285 obese females. 285 out of 285 out of 1295. Out of 1295 versus 222 out of 1205. I think we've grabbed this out of this versus, oopsies, not that one, this out of this. Okay, yeah, I didn't write the exam, thank you. Alright, let's calculate these as decimals, and then you can compare them, but they want us to calculate the relative risk. They don't ask for it, but I know that they want it. 22 versus 222 divided by 1205. This is 0.184. Okay. Right, we've got this. Now to calculate the relative risk. We do 0.22. We do this verse sign. We can replace with a big divided sign or a big fraction. A big fraction, and that means you always know which way around it goes. Okay. Stop cussing people out, Big Kahoot. Okay. Right, so if we do this relative risk calculations, we find the relative risk to equal 1.195. 1.196. Which is like saying that they are 19 or 19.6% more likely, or like saying 1.196 times more likely. Okay, so this number, the relative risk, is like saying you're 1.196 times more likely. That number is 1.196 times bigger, or like saying 19.6% more likely. Right? How many DPs? I'm using this many DPs because I'm doing lazy rounding, right? 1.196 or 1.1957, right? I'll do 3 to 4 DP, right? And in between, I wouldn't round too much. Okay. Now, what we need to understand is we need to answer the question. So, let's split this up a little bit and actually make sure we answer the question. Let's go look at the question. It says a recent survey of young adults found that females are more than 20% more likely. Okay, use the data to support your answer. Is the article correct? Okay, is this more than 20% is likely? Right? This is what I would write, something like this. It is, oopsies, close to 20% actually, maybe even in brackets, actually 19.6%, but they have said more than 20%, which is wrong and misleading. Okay, it's close to 20%, it's actually 19.6, but they have said more than 20%, which is wrong and misleading. If they said you are 20% more likely as a female to be obese than a male, maybe I'd say, yeah, okay, I'd give it to them, right? They've rounded up pretty aggressively, okay, but essentially they're not trying to fool anyone. Because they've said more than 20%, like that's like making it sound way more ridiculous, right? So I would say it's close to me, but they're exaggerating. They're trying to pull the wool over someone's eyes, right? They're trying to trick them. Let's see what the answers say. The answers say, right, to get excellence, because these are an excellence question, you have to comparison with 20%, but conclusion ignores strict inequality and rounds excessively. Comparison 20% and correct conclusion based on strict inequality. So this statement here, which is what we did, right? This is, as this is not over 20%, the article is not correct. Okay, you do that, excellent. Not too bad, right? We do one versus the other, calculate the relative risk, do the fraction, and write the sentence. That's your money excellence question, to be honest. I think that's the easier excellence. Let's move on. If there's any questions, throw them now, but let's move on. Right, this is a bit funky. I've got answers to flick back to, or working, but I've worked this out a different way to the answers. Okay, let's have a look. Survey obtained information about the smoking habits of participants. It was found that of the young adults in the survey who were defined as obese, so from young adults in the survey defined as obese, so from this group, right, 103 were current smokers. 103 were smokers. So out of this group, let's go like this. This is how I do it. Let's go, smoking's bad, so we're going to put it in red. Smokers and non-smokers is good, so we're going to put it in blue. Non-smokers. Right, we're going to set up a little, oopsies, little weird table like this. Right. It makes sense in my head. Right. Yeah, this is year 12 level 2. So we've got the smokers versus the non-smokers. So 103 were current smokers. So of this 507, oopsies, 103 were current smokers. That means the non-smokers, I'm going to use my calculator so I don't make a mistake. That means there must have been 404 non-smokers, right? Because of the young adults that were identified as obese, 53 of them were males. So there's 53 smoking males, which means 222 minus 53 will give us how many non-smokers there were. 169. With this information we can fill up the rest, right? If there's 103 smokers and there's 53 were male, then 50 fall in this category, and if there's 404 smokers, then 169 can fall in that category. Sorry, minus 169 will give us that. Okay, and these numbers should always add together to make the middle. Now they've set up in a complete different table. This sort of makes sense to me. This is how I did it before I looked at the answers, and it made sense. Right? Tell me if that makes sense to you. When they have this big space here, see this big space, they're often implying that you should set up a table. Right? You could do smokers, non-smokers, male, female, like this, right? And if that's easier for you, cool. For me, it was easier to set it up like that, how I did, and so I did it like that. Alrighty? So, let's answer the question. What proportion of obese young males, or obese young adults in the sample, were female non-smokers? So, 1 over pool. Our pool is obese young adults. How many obese young adults are there? Well, there's 507. And how many were female non-smokers? The female category, this category here, non-smokers, 235. 235. So 235 out of 507. What portion? Doesn't ask for percentage, so we can leave it like that. Let's see if we got it right. 235 out of 507. That's our answer there. Well done. Good. Fire away any questions about that. That's probably, what's that worth? That's worth a merit. Nice. That's a nice merit. Took a little bit of thinking, but not too bad if you set it up like I did. I just like setting it up like that. Okay. Cool. Next one here. Let's have a look. Table 2 below gives further information on the participants in the survey who were in the age group. Blah, blah, blah. Okay. It is claimed that a young adult. Oh, here we go. Another relative risk. It says risk. It is claimed. I see the word claim. I think relative risk. Do results of the survey support the claim? So the claim is that young adult smokers are more at risk of being obese than young adult non-smokers. So we're doing smokers. We're doing, what does it say? Young adult smokers are more at risk of being obese than young adult non-smokers. So we're going to do, out of all smokers, how many became obese, versus out of all non-smokers, how many became obese. Because if we just compared the numbers, if we just compared these numbers, you'd say, well, there's 103 current smokers that are obese and 404 non-smokers that are obese. You must be way more likely to be obese if you're a non-smoker. But there was 2,000 people doing that question, but only 420 there. So let's calculate the probabilities. So we're going to do smoker. Let's write it out. Let's go obese smoker out of all smokers. Let's make sure we're doing it in the right order too. The question says young adult smokers are more at risk than young adult non-smokers. So we do smokers versus non-smokers. Obese non-smoker out of all non-smokers. Oh, that's an S. I can't write. Okay. Yeah, I wonder if that was intentional too. Right. So the obese smokers, how many obese smokers are there? 103. Out of how many smokers? 420. Versus obese non-smokers, 404 out of 2080. Okay. Let's look at these two numbers. 103 divided by 420. 0.245 versus 404 divided by 20 is 0.194. Now what are we going to do with these two? We've got room over here. Oh goodness, that's ugly. What does RR stand for? Please reply in the chat. What does RR stand for and how do we find it? What does RR stand for and how do we find it? I'm going to put it over here, 0.245. While you guys answer that, what does RR stand for and how do we find it? Relative risk, good. And to find it, we're going to put one over the other. So this versus becomes a fraction. Right? This versus becomes a fraction and we put one over the other. Can we see how that's becoming a fraction? One versus the other, one over the other. 0. Because this is finding how much bigger is that number on the left. Relative risk, you find it by putting one over the other. Yeah, good. It's finding how much bigger is the left hand side number compared to the right hand side number. So we've got relative risk is 1.263. Okay. Now let's read the question carefully. It is claimed that young adult smokers are more at risk, right? Are more at risk of being obese than young adult non-smokers. Do the results of the survey support this claim? Well, you are 1.26 times more likely to be obese if you are a smoker. So you could say, so I agree with the claim. Okay, you could also say it's 26% more. You're 26% more likely, or 1.26 times more likely. Both are statistically correct things to say. Let's have a look here. Did we get it right? One risk correct gives us achieved. Oh, you don't even need to calculate relative risk. I always calculate relative risk when there's a claim question. Right? You could just compare the two numbers, but I always calculate the relative risk, and we get it. Nicely done. Okay. Good. Let's move on. Merino ewes. Now, there's a picture here, but you can't see it. So I will help you. Now, I'm no artist, but a ewe is a sheep. It's unhappy sheep. Okay? A ewe is an unhappy sheep. Right, now this one, my students got really confused because they didn't know what a merino ewe was. Right, they were probably reading it saying a merino ewe. Okay, but it's a ewe. They produce lambs. It's a mama sheep. Right? Now, the hardest part of this question is piecing together the information. So let's read it once, and then we'll re-go over it. Okay? Right, merino ewes that produce lambs usually have either single lambs or twins. These are some, I'm going to highlight things that I think are sort of important. So I don't think the merino ewes part is important. Either single lambs or twins. There's some two options. Right? Multiple births other than twins are extremely rare. Right? So we don't really care about multiple births. Either single lambs or twins. A long-term study has shown that 65% of merino ewes that produce a lamb will have a single lamb. So 65% are single lamb. And then of those lambs, 86%, so of those lambs, 86% survive until they are weaned. Now again, weaned doesn't really matter. Right? It just means separated from their mothers. But you can just think of it as getting to the next stage, or just living. Right? Of the ewes that produce a twin. So, remember we had 65% single lamb. Now the rest will produce a twin. About 1 in 5 of those, 1 in 5 lose both lambs. And then this last bit of information, approximately equal number of one twin or both twins survive. Right, I've read it once, it's a little bit confusing. This is the probability tree one. Yeah, perfect. The probability tree ones almost always look like this. A big bit of writing, and then a big gap for you to draw a probability tree. Okay, big bit of writing, big gap. So, let's have a look. Let's read the highlighted parts. Either single lambs or twins. 65% single lamb. I'm literally just reading the highlights. We know at the start there's only two options. It's either single lamb or twin. Sorry. Either single lamb or twin. What are the probabilities on either of these trees? Well, this one's 0.65 because that's what the piece I've highlighted, which means the other one must be 0.35 because they have to add to 1. Okay. Now, of those lambs, so let's read it. 65% single lamb of those lambs. So we're going up this tree, and I'm sort of like got my finger here, and I'm thinking of these lambs, 86% survive. So there's only two options in life here: live or die. Okay, it's quite grim. They either live or die. 86%, 0.86. If that's 0.86, this must be 0.14. Good. Okay, we've got live or die on that one. Let's keep reading. Of the ewes that produce twins, 1 in 5 lose both. Okay. Let's sort of order it nicely. Both die. Equal number of one twin and both twins survive. So let's make it say 1 live, 2 live. What do we know about this half of the tree? Well, it says 1 in 5 lose both lambs. So we know that this is 1 in 5. 1 in 5 as a decimal is 0.2. Just double check. Yeah, good. 0.2. Which means collectively, this piece here is 0.8. Right? And it says equal numbers of one twin or both survive. So if it's equal numbers, equal probability, I just split this in half, and that'll give me the probability on each of these branches being 0.4 and 0.4. Okay, get rid of that, and we've made our probability tree. Now it should take time to make that tree. You should double check it, triple check it, because otherwise it'll ruin the rest of your answers. Right. I'm happy with the tree. Looks nice and pretty. We're going to calculate bits as we go. Find the probability that A, ewe that gives birth to a single lamb, survives until it is weaned. So let's follow our thing. Ewe that gives birth to a single lamb, single, survives until it is weaned, lives. To find this, we times across the branches. I've gone 0.65 times 0.86. That's going to give us, yeah, good, laser kiwi. Ahead of the game, 0.559. I'm going to write this on the tree up here. 0.559. Okay, done. What proportion of ewes give birth to twins that both survive until they're weaned? So what proportion of ewes give birth to twins that both survive until they're weaned? So we are looking for twins that both survive. Twins that both survive, we're going to go along those two branches. 0.35 times 0.4. 0.35 times 0.4 is 0.14. Nice. Let's check our answers. 0.559, good, and 0.14, good. Fantastic. If the relative risk is under 1, how would you word it? Like, you couldn't say 0.89. You could say they are 0.89 times more likely. You'd say, yeah, that doesn't make sense, right? So we've done these two questions, so I'm happy to answer this question. We've got a question on relative risk. Right? If the relative risk is under 1, how would you word it? I would be inclined to say whatever the missing percentage is, that they're that much less. So in your example, you've said 0.89%. Sorry, 0.89 times more likely. I would say they are 11% less likely. You could say 0.9 as likely. Wouldn't be 1%, be 11%. Be careful. Yeah, 11. Good, man. Yeah, I would say I would probably go with 11% less likely. Shows your understanding of that. Okay. Good. Okay. Now things are going to start getting a little bit tricky, but let's have a look. What is the probability that a randomly selected lamb that survives until it is weaned will be from a ewe that produces a single lamb? Whew. Let's read it again. What is the probability that a randomly selected lamb that survives? Okay, so our pool, 1 over pool. Our pool is a one that survives. And until it is weaned will be from a ewe that produce a single lamb. So our pool is out of all the lambs that survived, and we only want the ones that come from the single lamb. Let's have a look at what that looks like. Our pool is, why isn't it moving? Oh. Our pool is all the ones that survived. This one survived, 2 survived here, and this one survived. So our pool is this one, and this one. We've got to be careful here because this one is times 2, because there's 2 in that pool. Right? It's probably not the best way to write it and highlight. Okay. Our want is single lamb survive. So we only want, oopsies, we only want the single lamb that survives. So we want this one out of all 3 options. This one out of all 3 options. So let's firstly write it. We know that a single lamb that survived is 0.559. It's out of all the ones that survive. Now we've got that one, and we're going to add it to this one and to this one, but we've got to be careful with this one because we're going to have to times it by 2 because that event occurs twice. If you imagine the lambs actually in a field and you're grabbing from here, there's 2 that would fall under this bracket, right? So 0.35 times 0.4. 0.35 times 0.4 is 0.14. Oh, I've done that just before. Okay, so it's 0.14 for both of these. Right? But this top one, I've not put that in the right place. This top one is times 2. Because there's 2 of those, it's twice as likely. So we've got 0.59 out of the 3 options. 0.559 plus 0.14 times 2, remember, plus 0.14. It's a really big fraction. Okay, it's our want over pool. This is conditional probability. The condition is that it's from a selection that survived, and we're grabbing only from that condition. So if we do this fraction, let's figure out the bottom first. 0.559 plus 0.14 times 2 plus 0.14. So this is equal to 0.559 out of 0.979 out of 0.979 equals 0.571. I think I've done that right. Yeah, good. Okay, 0.571. Okay, that's an excellence. Conditional probability is an excellence. Okay. 0.571, that's what we got. They do it differently. Don't stress about how they do it if my vision makes sense. If my vision doesn't make sense, look at their answers and figure out how they did it. I'm going to use their technique for the next question. Okay? So the next question. Now, I reckon these 2 is the hardest in the test for sure, and has been the hardest for the last couple of years. So it's good to do it. Right, lambing percentage is the number of lambs that survived until they are weaned, compared to the number of breeding ewes, expressed as a percentage. It is known that about 85% of breeding merinos actually produce ewes. So 85% of merinos, of the ewes, actually produce lambs, sorry. So what this is essentially saying is we can add on a little bit to the start. and this is produce and no produce, where you've got a whole bunch of ewes, only 85% of those actually produce, and then some survive. Some of the lambs survive. So we're like adapting our tree based on this question. Okay, so let's imagine we had 1,000 ewes. Imagine 1,000 ewes. Ewes. Right, so we're going to start with 1,000 here. Let's write it nice and big in this color. We start with 1,000 here. We're going to follow it along. Okay, so we start with 1,000, and if we times it by all the probabilities, we'll get how many are at each piece, right? How many actual ewes exist in each of these categories, right? We want to know how many survive, because it says here lamb that survive until they're weaned. We want to know how many survive. Okay, so we're going to do 1,000 times the big probability that it survives. Now we've actually figured out the probability that it survives. The probability that it survives is this one up here. See that? Is up there. So 1,000 times the probability that it survives is 0.979. Wait. The number of lambs that survive until they wean compare the... Yeah, that's right. Oh no, but we've got to be careful. We've got to be careful because we've got this 0. I knew I was doing something wrong. We've got this 0.85. Okay, so we've got this 0.85 times this plus this one and plus this one. So let's have a look. So we've got 1,000 times, let's do the top branch. I told you there's going to be lots of jumping around. 0.85 times 0.65 times, I'm just moving along this one, team, to get to that live one. 0.86. Okay, let's have a look. 0.85 times 0.65 times 0.86. This should be the same as this. So this number here in the brackets is the same thing as this times by what we introduced at the start. Right, it's the same thing. So I know to shortcut what I just did, where I bounced along here, I can just times this with the probabilities we've already figured out. And we don't have to double dip as much. Okay, so if we have a look, this is the same as saying 1,000 times, what's my number? 0.4715. I'm not going to do any rounding because it's in the middle, right? Plus. Oh. So that's only one piece of the people that survived. That's one piece of the people that survived, or the sheep that survived, and we want this one and this one. So remember, we can just do 0.85 times these two probabilities added together. Let's have a look. Plus 0.85 times 0.14 plus 0.85 times 0.14, and this one needs to be times 2 because it's come from this piece here. Remember, there's 2 in there. Now I know it's looking really, really ugly. This is the hardest question in the paper, I think. Let's have a look at this. Oh, 1,000 times 0.14 4715 plus 0.85 times 0.14 plus 0.85 times 0.14 times 2. Right. Typed in everything correctly. Let's get rid of all this. This equals 828.5. So this is, what is this number? Number of lambs. Okay, it's the number of lambs that survived. Right, it's the number of lambs that survived. Now to find this percentage, it is the number of lambs that survived divided by the number of breeding ewes. So out of all the breeding ewes, 1,828.5 lambs survived. Calculator's wrong. My calculator. Oh, 47. I see. 47515. Okay, so that's an okay mistake to have. Everything else is fine. Good spotting though. That should be 832.15. Right, so we're going to have 832.15 out of the 1,000. Good spotting, well done. Okay, I'm glad you're paying attention. And that's going to be our breeding percentage, 83.215. Oh, sorry. That's going to be our 0.83215, which means our percentage is 83.215. Whew. Let's check that we got it right. Didn't make any other silly mistakes. 83.2. Well done. They will accept decimal even, so we didn't even need to do the percentage. Okay, questions on this one. Right, I know that's tricky, and it's best to imagine with 1,000 ewes. Right, but if you just calculate all that number, it actually gives you the thing, but who cares? Right, doesn't need to be 0.85 times 0.35 times 0.14, not 0.85 times that. Okay, let's have a look at our probability tree. So it doesn't need to be... Right, so you're mixing up this number with this number. Right, to bounce along the branches, you type it into your calculator, you'll get the same thing. 0.85 times 0.35 times 0.4 is the same as 0.85 times 0.14. You've accidentally subbed that into here thinking that's that branch. If it was, yes, you're correct, but it's not. We got this already by doing the calculations. But man, I hope that makes sense there. So it'll be this times this times this would give us this, and this times this times this gives us this. Hopefully that makes sense. I know there's some delay, so I'll wait to see. But there's not too many questions on that. I know it's tricky. That is with an E. Right, but the other E question was the one before it. Not too bad. That's conditional probability. Good, Pitman, good. The other E question was conditional probability. That one is the trickiest E. Oh. Is this one E2? Oh no, this is the mirror. Okay. Right, this is a lot of writing for one question. Okay, that makes sense to me. Good. I'm glad this is making sense. Now I look at this and I just think it's too much writing for anyone. But let's read it slowly and make sense of it. And then we're finished with the sheep. We can move on to normal distributions. Then we're almost done. Okay. On Highbrook Station, there are two breeds of sheep, Merino and Romney. Okay. Table 3 gives information about the lambs born in 2016. shows a proportion of ewes that did not produce a lamb had a single birth or had multiple births. After lambs were weaned, the ewes were sorted, some were culled, blah 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 blah. Sometimes I like to read the question first. According to the data in Table 3 and 4 at the end of the 2016 season, what proportion of total breeding ewes on Highbrook Station were Romneys that were empty and were culled? Goodness me. So we're looking for culled and empty. Culled and empty. As well as the ones in Highbrook Station were Romneys. Right. Let's have a look. A single birth or multiple births. No lambs, single or multiple. What portion of the breeding ewes were empty? These were sort of some were culled and others were kept for breeding in 2017. At the end of the 2016 lamb season. Right, so that's now. Right. There's a lot of words, this is confusing. Okay, the ratio of Romney to Merino breeding ewes at the beginning of the season was 3:2. So Romney and Merino was 3:2. I know that's 60 and 40. Okay. So there's 60% Romneys. We only care about the Romneys, so let's only care about this one. We want Romneys that were empty and were culled. So how many were empty? From the Romneys, 0.06 were empty. Right? Oopsies. Empty, 0.06. And from the ones that were empty and were culled, no lamb, culled, 0.88. I think that should work. So it seems funny, but it should be okay. Let's do the math and see if it makes sense. 0.6 times 0.06 times 0.88. 0.6. Now, if you've got a better solution, tell me now, because I've done this before, but a couple of days ago. 0.03168. Seems quite small, but at the same time, not many of them produce no lamb, so that sort of makes sense. Let's check our answer. 0.032, 0.03168. Perfect. And that's worth a merit. If you tried and made a silly mistake by not including this piece of information here, then you still got achieved. Okay? If you tried and made a mistake, you still get achieved. But did the right mistake. Okay, last bit. Now this is the part we can whiz through because we have a graphics calculator. I'm not going to teach you how to do it without a graphics calculator. I'm going to skip. No, I'm not going to skip anything. I'm going to briefly touch the last question. We'll get into it. This one is where you can get the easy ease, I reckon. The easy ease. So let's have a look. Oh, we've got a blank picture. This should have a picture of a salmon, right? Oh, it's quite small. This should have a nice big picture of a salmon. Nice. Here's a salmon. The salmon's happy. Cute little salmon. Okay. Now, to do these problems, I have a saying. This is my saying. Draw the picture. Step 1. Do the math. Right? It's a Nike for math, you're not wrong. Right, do the math. Do the maths. Just me trying to be cool. Okay? Draw the picture, do the math. Draw the picture, do the math. Draw the picture, do the math. Right? That's a beautiful salmon. What are you talking about? We should have done it pink. Wait, look at this. Boom. Nice salmon. Right. Draw the picture, do the math. Salmon are grown in sea pens. I don't care. Each pen contains several thousand salmon. I don't care about that either. After 1 year in the pens, male salmon have a weight that are approximately normally distributed. Remember, wow, section 3 is normal distributions with a mean of 4125 and a standard deviation of 65. Draw the picture, do the math. Okay, let's start by drawing the picture. This is always the picture. Now we've got a mean of what? Mean is 4125. Now this is how I lay it out every time and how I suggest you lay it out every time. Okay, draw the little mean symbol, write the mean, draw the standard deviation symbol, which is this thing here, a measure of spread, and write the standard deviation. I lay it out like this every single time. Less room for error. And then we have a look, all my lights are flashing. Right, find the probability that after 1 year in a pen, a randomly selected male will weigh between 4125, so between here, and 4200. Is 4200 to the left or to the right of that number? Is 4200 to the left or to the right? I'm expecting an answer in the chat, please. I'll tell you now, it's 4200. And we shade in the area. Okay, Spaghetti's tuned in for a funky little part. Right, we've got that shaded in area. Good, good, good. I can see you guys saying the right thing. Right, now this is where you need your graphics calculator. So grab your graphics calculator and press these buttons with me, please. We go to stat, which is option 2. Which one of these? Well, we're doing distribution, so we're going to go dist. We're doing normal distributions. You can see it where it says normally distributed, so we go norm. And NCD or inverse normal are the only two you're going to deal with. Now, when we're doing in between two values, it's NCD. See that one, right? See that shaded in part. We're doing this one. Now we do our lower and our upper. Our lower is the number on the far left. In this case, is actually by chance the mean. Our upper is the one on the right. Our standard deviation, look, I've written the symbol so I don't get confused, 65. Our mean, I've written the symbol so I don't get confused. Man, I'm clever. Okay? And we execute. Boom. The first number is what we care about. P equals 0.3757. Right, again, 3DP is probably your safe bet. I did that so I don't have to round because I'm lazy. Right, 0.3757. Easy, easy, easy achieve. We're going to move faster now. Okay? What is the maximum weight of the lightest 10%? Now this is a little bit confusing. So I'm going to draw the picture and do the maths. Maximum weight of the lightest 10%. Hold on, I've missed some things from my picture. The mean is 4125. The standard deviation is 65. Right. The maximum weight of the lightest 10%. So the lightest 10% is at the bottom. Right? The lightest 10% will be down here somewhere. And we want the maximum weight. I'm going to call this X. Now what do we know about this? Well, we know that this shaded region is 10%. Let's say 0.1 in brackets. Okay, and Lazy Kiwi is ahead of me. And this one, when we know the probability and finding X is when we inverse normal. Right? We don't see the thing, we are inverse normally. So distribution normal, inverse normal, and it makes sense because this is where we have tails and middle and things like that. Now the tail is to the left. The tail is to the left because it's coming from the left hand side. The area, I've highlighted it. It's all streamlined so that you can do it in your calculator. It even saves your things. So now it's telling me my value of x, this x here, is equal to 4041.7. So the value 4041.7. The heaviest of the bottom 10% is 40417 grams. Let's check our answers. 0.3, 4042, 40417 is also fine. Achieve merit. Accept correct answer only. So you don't need to use this formula. We just accept the correct answer only, which is this, because they know you can use your graphics calculator. Easy, 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 easy merit. Inverse normal is the dream. Okay, let's move on. Right. After 1 year in the pens, female salmon weights have approximately normal distributed with a mean of this. Then what would the standard deviation be? Okay, normally I tell my class to just skip these questions when the question said what would the standard deviation be, when you either have to find, if the question says find the SD or find the mean, I normally say skip it, but I'm going to show you how to do it now because it's not too hard. It's just a little bit confusing. Right, you can still get excellence by skipping it if you tactfully do it, but let's look at this one. Right, we need to remember the formula. Oh, I always forget the formula. They should give it to you in the exam. What's the formula? X minus Z? I always forget it. Hold on. I wrote it down. X minus the mean. Right. Thanks, Laser Kiwi. I always forget that one because I barely use it. Yeah, you guys are way more onto it than me. Good, good, good. Right. Okay. So we have, let's draw the picture first. Weights are approximately normally distributed with a mean 3975. 40% exceed 4,000. What would the standard deviation be? Right? And to do this question, we need to do a process called, I'm just going to put this in a box. Might even move the box a little bit. Here. To do this question, we need to do a process called normalization, or normalizing. Right. Now, there's some people tuning out because it's getting a bit tricky. We've been here a while. That's fine. Before you go, please, exclamation form would be fantastic, and fill in the form. But we're getting on to the last two E questions. Or the last. We've got 3 questions left, team. 1, 2, 3. We've got 3 questions left. Tune in if you want, or if you're ready to call it quits, no worries. Exclamation form would be amazing to fill in. Takes 5 seconds. Right, normalizing. So the process of normalizing is where you have a standard deviation of 1 and a mean of 0, which is your standard normal curve. This is 0 and your standard deviation is 1. Okay, don't stress too much about that. Let's just do the process of normalizing. So we're going to do our standard deviation. We got our tail is right-tailed. You can see that there. Right, and our area is 40%. But this time we're going to standardize it by going like this. So I've put my median of 0, my standard deviation of 1, and I calculate this. But this x is actually your z-score. Is actually your z-score. So we can then use, let's move this a little bit to the side as well. Right, this x is actually your z-score. So we can use our z-score to, let's go like this, here, in this formula to find the standard deviation. So our z, 0.2533. Our x is 4,000. I'm going to run out of room. Don't care about that. Minus our mean, 3975. All over. Well, we want to find the standard deviation, so we leave it there. Right? Let's figure this one out. 4,000 minus 3975 equals 25 over the standard deviation. So our standard deviation should equal 25 divided by 0.2533. So our standard deviation is 98.7. Let's make sure I did that right. Boom. We normalized, and then used the formula. Normalized formula, normalized formula. Okay, not too tricky. A little bit weird, but mathematically not too hard. Normalized formula, solve. Okay, let's move on. Right, if you're still there, say hello in the chat. There's still some people still here while we finish off, and then we'll call it a night. You go relax or do some more study for something else. Who knows? The pens contain approximately equal number of male and female salmon when they're harvested. The weights of all salmon are approximately normally distributed with a mean of 4050 and a standard deviation of 84. Right, this is a nice easy merit question, I think. Alright, we've still got some people here. Awesome. Okay, when the salmon are harvested, each member of the harvest is given 2 salmon to take home. If these 2 salmon are selected at random, was the probability that both are more than 4025? So where's 4025 on here? It's to the left, 4025, and it's anything above this. Draw the picture, do the math. Oh, Kristen's gone. Right, distribution, normal, NCD. Right? So, our lower, you can see, is 4025. Our upper is a really big number because it goes to infinity. Right, this curve goes to infinity, so that would go to infinity. So it's a really big number. Our standard deviation, I've written it in the same place, and our mean, I've written in the same place. Cool. Now the probability, 0.617. Okay, but the weird part is it says if I select 2 salmon at random. Now this is almost a combination of probability trees and normal distributions. Right, but you can also just think of it as the probability of getting 1 is 0.617. The probability of getting 2 in a row is 0.617 times 0.617. And you can see that like this. What are we doing? Size, not size. 0.617. Right, the size we want, not size we want. 0.617. Can you see how that works out? Oh, I missed my S. Yeah. Okay. We got the size, the one we want, and the not size, and the size we want, and the not size. Multiply, multiply, and you get our number. Yeah, makes sense. Awesome. 0.617 times 0.617, 0.381. Fantastic. Did we get it right? 0.381. Easy merit. Well done. 2 questions left. And it's really only one. Right, let's look at this one. Now, you see this, it's always going to be in the exam. You're going to have 2 distributions, sometimes 2 normal distributions, like this might actually be a curve, or sometimes a histogram like this, and you need to sort of look at the histogram. Right, but firstly, let's look at this question. What proportion of the salmon in the sample had weights which exceeded 4,000? So this is our sample. Let's look at the context, right? We've got a bunch of salmon is harvested. This is the expected, is figure 1, and the actual, the sample, is figure 2. So it's like expectation versus reality. I know these take ages. They do. I'm not going to write the whole thing. I'll just give you some bullet points. Right? What proportion of the salmon had salmon? I just said camel and salmon together. Whoa. What proportion of the salmon? No, maybe I said sample and camel. Oh my gosh. My brain. Salmon in the sample had weights. You can read it. Where's 4,000? 4,000 is here. We want anything over 4,000. All of this. Oh, that's a horrible color to do that in. Oh. That's okay-ish. Right? So, let's find out how much exists in each bar. This is going to be annoying. Let's go like this. Right, in this bar, we have 7 values. Tell me if you get confused by this, because this is easy to achieve. In the next bar, we have 14 salmon, 14 values. In the next bar, we have 10. And the last bar, we have 4. I'm reading it from here. Okay? Right. So total 7 plus 14 plus 10 plus 4, which is 7 plus 14 plus 10 plus 4 is 35. But then we want proportion, so it's going to be 35 out of however many there were total. There was 50 total, you can see it up there, 50. So 35 out of 50. We can even figure it out if we want. 35 out of 50, 0.7. Easy achieved. 35 out of 50, make sure we got it right. Good. Fantastic. Right, last question. I know what it's going to be, you know what it's going to be. The comparison one. Right? Compare the probability distribution and the histogram that resulted from the sample results. So compare the expected versus the sample, what actually happened. In your answer, you should consider shape, center, spread, and numerical evidence where appropriately. I honestly leave it as a fraction almost every time, but convert to DP if you want. It's just one more step that you don't need. Oh, okay. Compare the probability. Compare means you say this is something while the other is something else or the same. All the empty space makes me depressed. Right, all this empty space should make you excited because you know it's worth excellence and you know exactly what to write. Write a comment on shape. Write a comment on center. Write a comment on spread. Mirror, easy. Write 2 on one of these and include some numbers. You're probably on excellence. Right. Let's not write it ourselves. let's have a look at something I wrote earlier, if you guys are happy with that, so we don't have to just write the whole thing, and go piece by piece. Ugh. Right, my handwriting's pretty terrible. You'll get over it. Right. Shape. The expected distribution for salmon. Right. What you need to realize is the for salmon part and the expect is really important because this is using context. Right. Context is king, as Mr. Singh would say. Context is king. I'm going to highlight every time I feel like I use context. Right. The expected distribution for salmon weights. Oh, look, I even added that in because I felt like it wasn't enough. Is perfectly normal. That's a description of shape. I could even highlight that like this. Being symmetrical. So symmetry is a key word. Around the mean of this. I mean, that's also center. Look. And numerical evidence. Look. Yuck. Look. Okay. Whereas, so we're comparing now. Whereas, the harvested distribution, oh, some more context, nicely done, sir, of salmon weights, good, has considerable left skew, that's also shape, and is bimodal. Expected is unimodal, because I'm comparing the two. Harvested has two peaks, one at this and one at this. That's a measure of modality, or mode. Right, let's read the next bit. The expected distribution has the same mean, median, and mode. Right? If it's a normal distribution, if it's a perfectly normal, the mean, the median, and the mode is all the same on a perfectly normal distribution. Right? At 4,050 grams. You can see that quite clearly on the thing here, on the picture. 4,050. I'm just reading it off the graph. Okay? However, the harvested distribution has a median more around this. I just guessed that. I just looked at the picture and went, oh yeah, median looks around here. Remember, it's the middle of the data. There's a bit of data here, so it's probably pulled up slightly, maybe here-ish. I just guessed that. Okay, you could calculate it with the calculator. I'm not going to show you how to do that right now. Because asymmetrical. The range, this is the measure of spread. The range of the expected value is, of the expected, look, I've forgotten to highlight, but if you use context there, is mostly between this many grams. I've calculated the actual range, whereas the range for the harvested is 350 grams. This means the expected is more spread out. I've even interpreted the data. Let's see what we needed for excellence. Four valid comparative comments about different aspects. So, with numerical justification for at least 3. Let's look if we've got at least one from every category, right? Let's look what we got. Shape, boom. We talk about symmetry and modal. Center, we talk about the mean, median, and the mode at this. We also talk about the mean up here and the median here. So we've talked about 3 things, not really the mode that much. Okay. Oh, we did talk about the mode here. Then the range. We talk about the range measure of spread. We only really mentioned spread once. Okay. So we've definitely done 4 comparative things. We've definitely done 1 from each. Numerical justification for at least 3. Mean of 450. There's 1. Peaks at this and this. There's 2. Mean, median, and mode here. That's sort of crossover. Median. That's 3. And the range. The range is an easy one to calculate. That's 4. Numerical evidence for 4. They only need it for 3. I'm at excellence. Right. And here is suggested 7 things to talk about. Right. Ignore that. Symmetry is an easy one. Let's highlight the nice ones. Symmetry is nice. unimodal or bimodal is nice, and talking about where that is. The medians you can sort of guess is nice, and the range is really nice. Okay, that's what I would suggest. Now I know it's a lot of writing, but you've just done lots and lots of maths. Take a break and then write this all out. So get to the stage and go, whew, okay, I'm ready. Have a read, have a think, highlight the bits that you need to write, and write as you go. Okay. Any questions on this or the whole paper? Any questions on this or the whole paper? Cole Magoo, welcome back, my dude. The throwback life. If you're done and dusted and you're like, sweet, done, moving on. Exclamation form, please, please, please complete the form. That would be amazing. If you don't, such is life. But if you can complete the form, that would be great. It's in the stream title. It's year 12. Mad. Yes, I'll post it. Hope that was helpful, guys. There wasn't too many people here tonight, so there weren't very many questions. So I just talked and talked and talked. But hopefully you found it helpful. Oh, what paper is it? Did you say? Oh yes, we're gonna do a Kahoot too. Kahoot time. Kahoot time. Kahoot time. Oh, almost showed you the answers. Right, Kahoot music or other music? Let's get a poll. Kahoot music or royalty free music? Yes, I'm gonna upload it to YouTube, team. Don't worry. Kahoot royalty free. Right, you guys choose. Oh, Resident Sleeper, get out of here, Bumble. You know you love it. Okay. Also vote what music you want. Well, student, will I see you live stream next year? I'm not live streaming year 13 calc. I'm so sorry. Okay. The code is. Go to last page. The code is 1627804. Kahoot.it. Okay. Yeah, we're student. I'm really sorry, man. I tried my best to get into year 13 calc, but couldn't do it. No worries, team. Thanks for tuning in. Laser Kiwis in the game. Let's get everyone in the game. Come on, team. Ross Killian's here. What year is this paper? Yeah, 2017 paper. Sorry, I'll upload it to YouTube and it'll say everything. Right, Spaghetti's been here silently. What a silent mod. He's been a silent mod this whole time. Why am I here? I don't want NA. Have we voted on the music? We've got 2 votes Kahoot, 1 vote royalty free. You got like 30 more seconds to vote on what music you want. Right, and we're going to try to get at least 15 players in the Kahoot game. You have to play, Spaghetti. Come on. Haven't done prop for 1 week. Exclamation YouTube Top Hat Penguin and you will get it. Exclamation YouTube, you'll get it. You want to play Fortnite? Exclamation Fortnite? Ah, no Fortnite tonight. Unlucky, dude. I genuinely might play some Fortnite tonight. I downloaded Destiny 2 for free and trying to play that multiplayer. It's so stupid. You have to like play or play like 3 missions in the campaign before they unlock, before they give you like multiplayer. And I just wanted to try the multiplayer. Okay, looks like we're doing Kahoot music. Oh, royalty free's just got ahead, but I feel like the Kahoot music. Pumbula, get in the Kahoot. Do I grab my phone? That's the question. Alright, where's Kahoot? Oh, yes. Tell me if that's way too loud. Sounds quite loud. Right, are we ready? Should I get my phone? If you can beat me, you straight away get mod. Okay, if you beat me, you get mod insta. Oh, yo, Kahoot's already open on my phone. Right, give me 2 seconds. 1627804. Oh, Dango, forgot about it. Unfair modding, come on man. Alright, we ready? Nasha Maths is in. Okay, we're gonna full screen this. I'm gonna get rid of this. We're gonna move me, I think, upwards. Right, I think we're ready. Oh, I just stole this from the internet. I don't know what the questions are, genuinely. Independent events are events that... Oh, I need to move there. If someone guessed straight away without having seen the thing. Wait, why is there only 2 people in here? Oh, it's a really... Oh, the time is so short. The time is so short. Hold on. The time is so short. No. Sorry. Let's end game. I need to edit that. How do I copy it? Duplicate. Okay, let me set this up. Oh damn, the timers are so short. Go into this one. Give me 2 seconds, team. I didn't even think about the timers. How do I fix this? Go into it. How do I edit it? Edit. Boom. Okay, timers. 60 seconds each one. Right, 60 seconds is heaps of time. Yo, do we have to restart the Kahoot again? Oh, damn it. Sorry, team. Right, we're good to go. Save. And play. Classic. Yo, you guys got no time. You gotta join. Let's go. That timed out is so funny. I got it right though. Not gonna lie. Okay. New code. 1695976. That's crack up. 1695976. We're gonna join super fast. Go. 1695976. Oh, the real Tyler's in here. Right. What's our Twitch rankings on the science and technology category? Can someone look that up for me? Spaghetti. Look up how many streams, what stream we are. Alright, we're gonna get to 11 players and start, because I think that's how many we had last time, right? we ready? Spaghetti, I'm waiting for you. We're not gonna start till you're in here. We're fourth. Let's go. Let's go, baby. That's fourth twice in a row. Imagine if more people cared about their grades and joined the stream. Don't wait for me. Haha, I like it. Okay, let's go. Fourth on science and tech. Nice. Okay. What's the stream delay? What's the stream delay? Because I'm too quick. I think everyone knows this answer already. It's not fair. We're coming for the top spot, boys. When everyone sees Kahoot going off, they're gonna know what's good. We've got heaps of time to answer this. Spaghetti, don't hold us up. At least just spam something. Alright, nicely done. Ooh, okay. Don't really need to know this for the exam, to be honest. But it's a good starter. Independent events are events that don't affect each other. Right. Oh, way on top. Yo, this was get in there quick. Find the probability of buying a soda. Oh. I need my calculator. Yo, got it. I was a bit slow there. No. The stream quality is good. We're at 30 frames, probably not the best. We've got a good webcam. HD, I'm on a 1440p monitor. Haven't dropped any frames. Pretty solid. Yo, nicely done, team. Right. Good. Don't have me as high as a climber. Okay. Bought water and pizza. Oh, I need my calculator. Ah! Where's my calculator? Psh. Oh. Ah. Oh my gosh, my phone's turned off. Oh, that's your chance. That was your chance to get ahead, team. Classroom perfection. Oh, this is intimidating. Oh, some miscalculations. Can't beat me. Found the probability of bought water when having pizza. This is conditional probability. When having pizza. Oh, I thought I had my calculator here. What? Oh, the answer's there. Whoo! Music is scary, yeah. They got rid of the Halloween music though. Halloween music was way scary. Diminutive, just throwing out answers left, right and centre. Good. That's looking good. I think we got some people guessing. Oh, almost kicked me. Good team. What does this one mean? Ooh, we should know this. I'll give you 5 seconds. 4, 3, 2, 1. What's the stream delay? Okay, I'm going to say a number and you have to type the number back into chat as soon as you hear the number so I can calculate the stream delay. Okay, the number is, hold on, 8. Wait, that doesn't work out. I stopped counting. Nice, we all got it. Good, good, good. Okay, I'm gonna do a number again. Let me count this time. I'm gonna do it straight when the buzzer goes. Right, the number is 4. Okay, so my stream delay is like probably 10 seconds. 10 to 13 seconds. Right, I waited until you said 4 before I clicked my answer. Right, so I'm going to wait 10 seconds before I answer. How many questions do we have left? We probably only got like one question left. I'll wait 10 seconds. Officially 10 seconds. I'm only allowed to answer when that countdown goes to 50. Let's go, team. We should know this one. I'll give you a hint. Looks like uTorrent. What do you mean, uTorrent? What do you mean, uTorrent? Or what does uTorrent mean? Think of like an old person that don't know what uTorrent is. Good. Oh, not Z. Z is the seed score. Right, I'm going to wait till 10 seconds. We've got 2 questions left. Salmon or rubbish has a mean of something and a standard deviation of something. I've got my answer. I waited. I had to wait. Yeah, diminutive. I don't know where that's going. I'm scared. This is too easy, boys. Do you get my Twitch account if you win? I'll host you. You stream, I host you with my 18 viewers. Or I'll cast you playing Fortnite. I'm a good Fortnite caster. You're not too bad at Fortnite. Worse than me, but not too bad. Someone's just guessing, surely. Oh, they got it around the wrong way. Don't wait for me. I'm still on top. Based on the estimated data range, was the best approximation of the standard deviation. Oh my gosh. Oh, I don't know what the right answer is here. I don't know if that's right. Okay, I stream you playing a game that I can stream you. Like what could I cast you in? Spaghetti. I don't know if I got that right. I might have to give a mod out. No. This is a hard question. A lot right on this. Still waiting on one more person. Oh no! No, 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 no. Oh no! No, no, no. I don't want to click next. I don't want to click next. What? One standard deviation is 60%. No, no, no. Spaghetti, I don't know what you're talking about. I don't know what you're talking about, Spaghetti. I don't know what you're talking about. I don't know. I don't know what you're talking about. Thanks for watching. Let's get some royalty-free music going. Divide range by 6 to get approximate standard deviation. Oh, I was just looking at it. Uh-oh. Uh-oh. Not good. Not good. Uh. 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 Not good. GG. It's more like this. GG. Whelp like this. Rip nutshell maths. Right, Spaghetti, where's your channel, dude? I have to host you now. Or I cast you playing a game, right? That was the deal. Host you or cast you. I'm not gonna cast it on this channel. I cast it on my other my personal Twitch. Not this Twitch. Right. It doesn't want me. Done. Easy. Thank you. That's why you're a mod. That's why you're a true mod, Spaghetti. Okay. Wanna play League? Nah, dude. Right. Thanks for watching, team. Right. There's heaps of lurkers here. Really appreciate it. I know you're just sitting there watching. Appreciate it a lot, guys. I'm gonna message Spaghetti and see what I own. But thank you so much for watching. Thank you for playing the Kahoot. All the best for your exam. It is when. Someone tell me when the exam is, so that I don't lose all faith in you. It's just underneath the channel. It's just underneath the channel. Right. When is your exam? Is it morning or afternoon? Don't make the mistake. One of my best, like really good friends, literally missed when the exam was. Wednesday. 14th. Morning. Get there nice and early. It's on Wednesday, my dudes. Get there nice and early. Make sure you're ready for the exam. Bring all your stuff. Know how to reset your calculator. You will be great. You guys the real MVP. Work hard. Play harder after the exams. Okay. Why aren't I doing algebra? Because I don't teach algebra, so I don't know it that well. That's honestly the real answer. Okay. There's lots of good stuff out there. I've heard Learn Coach is really good. Oh, big gap there. Learn Coach I've heard is really good. Right. But check out the YouTube. Oh no, if you've tuned in, you don't need to check out my YouTube. Tell others about the stream. Tell others about the YouTube channel. Nutshell Maths. Right. Pitman could have got mod, but he's stuffed up. He or she. Right, I'm out of here. I might go play some games. Have a late night. It's Friday. Oh my gosh, it's Friday. Have a good one, team. Enjoy your weekend. Music's pretty goey. Thanks so much for watching, and I will see you next time.
Guys, some ammo, please.